We started with a parabola. Remember, they open up or down, left or right. That determines on whether it's y equals or x equals. For parabolas, your HK flip-flops from what you think. All right. So in a parabola, it's typically we had y equals a. Remember, a is 1 over 4p. But you always put your a there. Don't give me your p. Your formula is going to put your a there. It's just telling you how to find your p if you have your a, or vice versa, how to find your a if you have your p. All right. X minus h squared plus k. The h is already subtracted. Okay, that's important. If it is left-right, it is y minus k, meaning your k is negated and your h is adding there. Everything else is the same. So just pay attention to which way it opens. All right, and that's going to tell you which direction those things are going to go. All right, and then you have, of course, your y value changes when it opens up and down. That makes sense. So you take your y portion of your vertex and you add your p to it for an up down. If it opens left right, then your x value is going to change. So you're going to take your x value and you're going to add your p to that one as well. Your vertex is always at HK. It's just where they are in the formula flips. Okay, so your center, your vertex is still going to be at HK. It's just where they are in the center. The next one when I'm looking at a parabola, one of my variables is going to be to the first power. One is not. That's a parabola. So the first thing I'm going to figure out is which one is to the first power. I need him by himself, right? So when I look at this, my y is to the first power. That guy needs to be by itself. Everything else needs to be moved over. So keep him positive. If he's positive here, keep him there, move everything else over. If he's negative, move him over, all right? It's pretty much what you're thinking. So in this case, I'm moving everything over to the right, leaving my y by itself. So I am going to end up here with y equals x squared. That becomes positive. 8x becomes positive, and my 13 becomes positive. I moved all those over. This is not vertex form. I need it in vertex form. I do that by completing the square. Now, because all of these are on the same side, this is where I'm going to plus minus, right? For my ellipse and all those other guys, you can add to the same, add, subtract, because you're actually doing along two sides of the equation. You're keeping the equation balanced. Here, you're keeping the equation balanced by add, subtract, all right? So when I complete this square, I'm going to change this guy. I'm going to pull out the x plus 4, right? Divide that in half. So I have x squared plus 4x. It actually looks like this. Square it. But remember, when I do this, that takes care of my 8x, but I actually technically added a 16 in here. If I were to FOIL this, I would get x squared plus 8x. I added a 16 by doing that. Because it's on the same side of the equation, I need to subtract a 16 here with that 13. If there had been anything that I factored out, all right, let's say I factored out a 2 to get that x by itself, I would need to multiply that 16 on the inside by 2 because technically I added 32 there, all right? So any number that you factor out of that, if you have to put the parentheses and factor a number out, you have to multiply the guy by that number to subtract him again. All right, questions on that process of completing the square. When I simplify this, my vertex formula then looks like this. Y equals x plus 4 squared minus 3. I already have my a, I have my h, and I have my k. All right, so if I'm finding the vertex, that's the first thing it's asking for. And by the way, I would go through and make sure I answered every piece of this. They're a point a piece. Do not leave them. And do not assume because you graphed it that I'm going to give you credit for it. I need you to label it. All right. I need you to know. I need to know that you know what you're doing, right? That you just luck of the draw didn't draw it. All right. So vertex, you need to actually tell me what your vertex is. My vertex in this case, because it's a y equals, this is h, this is k. Remember, this is opposite of what it looks like. So my vertex here is -4, -3. All right. -4, -3. My focus. So if I take my focus, I need to figure out what my P is to figure out my focus. This guy's opening up and down. Vertically, it's opening. So my vertical coordinate is going to change. My vertical coordinate is my Y coordinate. All right. Here, my A value is a +1, right? right here. That's a positive 1. My P is going to be 1 over 4 times my A value. P is 1 over 4A. I need the P to be able to find my focus, which means my P is 1/4. So I'm going to take my vertex, I'm going to leave the -4, but to find my focus, I'm going to take that -3 and add my P, right? So my focus here is going to be -4. This is -12 force plus 1 force, so this is a -11 force there. So that is my focus. All right. My directrix is exactly the same thing, but I'm just going to subtract from that 3. So for my directrix, I'm going to keep my x value the same. Again, it's my y value that's changing. So I'm going to start with my vertex, and I'm going to subtract my p value that I found. All right. So this becomes -12 force minus 1/4 is -13 force. So my directrix looks like this. All right. The only thing I haven't answered is my axis of symmetry. So I've answered my focus. I've answered my directrix. I just put those together because they go together. I add to my y value, I subtract from my y value, right? My axis of symmetry we've known for a long time. My axis of symmetry, if it opens up and down, is going to be a vertical line at the vertical point of my vertex. So my axis of symmetry kind of goes along with this guy right here. If it opens up and down, it's going to be an x equals whatever the x value is, -4. So that is my axis right there. Those two go together. If it opened left and right, it would be a y equals, right, of my y value of my vertex. That's my axis of symmetry. So now I've answered all of these questions, and I can graph it. I always start with my vertex, -4, -3. So that is right here. My axis of symmetry goes right through that guy. If it opens up and down, he's going to be the x equals. So we have a vertical line here that is my axis of symmetry. My focus, that's going to be a little bit above him. So we have -2 3/4. So he's about right here. He's not that far above it. My directrix is kind of right below it. We're at -3 1/4. So he's right here. If you need to know exactly where it crosses the x-axis, that's just wherever this guy equals 0. So if I set this guy equal to 0, y equals, well, we'll go and write 0 there. 0 equals x plus 4 squared minus 3. 3 equals x plus 4 squared. So we have the positive and negative square root of 3 minus 4. So we're going to get it crossing a little bit over here. If we were to plug that into a calculator, we get -5 and something, and we get -2 and something. Looks like that. X-intercept is just where y is 0. If it opened the other way, it would be y-intercept where x is 0, right? So it just depends on which way it opens. If I want just, all I'm asking for is the vertex form of the equation. So whatever you need to give that to me is all I need from you. To give me the vertex form, you need A, H, and K. That's literally all you need to give me vertex form. You do need to know which way it's opening. That's important, right? You can tell that by which coordinate is moving. They gave me vertex. My vertex is my H and my K. So they gave me H, they gave me K. From there, my focus tells you which way it's going. Which way is this going? Up and down or left and right? Well, my y value, my vertical value is moving, so it is moving vertically. So I know that this is going to be a y equals a x minus h quantity squared plus k. If my x value had moved from there, I would know that it would be an x equals y minus, right? Y time minus h or k plus h, all right? So pay attention to which way it's going. That's how you're going to be able to tell which formula you're using. So I already have my h and my k. I really just need my a. I am going to figure out my a based on this focus. I know that if it is moving, my vertical is going to go from, so if my center is negative 1, 4, then my focus for this guy is going to be negative 1, 4 plus p, right? That's what I do there. I move my vertical. So I really just have to set 4 plus p equal to 15/4 to figure out what p is, right? So I'm going to take this guy and set it equal to that. 4 plus p, because I know that's my center, should equal 15/4, right? So we're just going to subtract 4. 4 with a denominator of 4 is 16, right? Right? 16/4. 15/4 minus 16/4 is negative 1/4. That's my p. How does that help me? Because I need my a. And I know what my a is. What is a in terms of p? Right, it's just flip-flopped, right? It's just 1/4p. So if I need my a and I have my p, I'm going to say, well, a equals 1/4 times p, which was, they were very nice to me. A is negative 1. All right? So I have my a, I have my h, I have my k. That's all I need for vertex form. I'm done. I'm just going to rewrite it. Y equals my a, which is negative 1. X minus my h is negative 1, minus a negative 1 is plus. And then plus k, plus 4, I am done. Talked about was an ellipse, all right? Ellipse is just a circle that is skewed, all right? So if your A and B is the same, then you have a circle, pretty much. If it's anything else, you don't. Remember, this guy is determined by which one's bigger. So if your larger value is under your x, then it's going to stretch on the x. If your larger value is on your y, it's going to stretch on the y. All right, you still have your HK. It stays with your x and y. So your h stays with your x, your k stays with your y. Really, the only thing that changes here is the larger value being under one of those groups, okay? That's what changes here. And that's going to affect everything else. So your vertices, if it opens on the x, then your x vertice is going to, your x value of your vertice is going to change. And then your smaller co-vertices will change by the y. If it opens on the y, then your vertice, your y value is going to change by the a, your larger amount, and your x is going to change on your co-vertices by the smaller amount, okay? Always plus and minus because it's going to go up and down. All right? So, and remember, you can solve for your c value, which you use for those focal points, using your Pythagorean, right? A squared minus b squared for this guy. A squared minus b squared. Your larger value minus your smaller value, and take the square root, and that is your c. All right? And then in this case, I need both of them squared on the same side of the equation. So I'm going to move everything with a variable to one side, and I'm going to leave everything without a variable on the other side until I get to the very end, and then I'll divide that guy out, because technically I need it equal to 1 by the time I'm done with it. But until I'm done with it, leave your numbers on the right, put your variables on the left, okay? Or wherever they'll be positive. So I'm going to group my x's. I have 25x squared plus 100x. I'm going to move this y squared over. So I have plus y squared, group it with the negative 4y, and I'm going to leave the negative 79 over here. All right? Then I'm going to do my completing the square. To complete this square, I need to factor out a 25. All right? So if I factor out a 25, I have x squared plus 4, right? Plus 4x. I need to complete this square. To complete that square, divide the 4 in half and square it. So you get x squared plus 4x plus 4, right? That is completing the square. I write it like this. Cut this guy in half. X plus 2 quantity squared. And we still have this 25 out here. Here's the issue, though. I added a 4 in here. If I added a 4 in there, I have to add a 4 to the other side. However, this 4 is being multiplied by this 25. So what did I technically add to this side? I added 100, right? When I completed this square, I added a 4, but inside the parentheses, it's being multiplied by a 25. So over here, I don't just add a 4, I add a 100. So I have a negative 79 that was already there, and I have to add a 100 as well. All right, let's complete the other square. For this guy, divide him in half. So we have y squared minus 4y divided in half is 2, squared is 4. So I'm going to rewrite him just y minus this guy in half, 2 quantity squared. I've added a 4. There was a 1 on the outside, so I literally just have to add the 4 to the other side. All right? Remember, you're doing it on the different sides of the equation, so you do the same thing. Don't do the opposite. You only do the opposite on the parabolas, okay? You're doing it to both sides of the equation, so it has to be the same thing, not the opposite thing. All right? So over here on this side, negative 79 plus 100 plus 4 gives me a beautiful what? What does it give you? It should give you 25, right? So these are always going to work out nicely. I'm not going to give you a number that's still on the outside. So you end up with 25x plus 2 squared plus y minus 2 quantity squared equals 25. Now I'm ready to get rid of that 25 with division. Divide everything by 25. Reduce it, 25 over 25, I get x plus 2 quantity squared. We have y minus 2 squared over 25 equals 1. Which way is this going to open? On the y or on the x? Or elongate, rather. On the y, 25 is clearly bigger than 1. They do ask for several things here. They ask for the center. The center is HK. So the center is still this and this. Remember, it's opposite of what you think. So my center is going to be negative 2, 2. They ask for the vertices. Remember, the vertices are the one where it's elongated. So your vertice, if it is elongated on the y, should follow the y. So I'm going to take my center. So for my vertices, I'm going to leave the negative 2, and I am going to change the 2 by what's under here. Remember, what's under here is squared. So I'm not going to add and subtract 25. What am I going to add and subtract from my y value? 5. So I'm going to say 2 plus 5. That's my first vertice. My second vertice, leave the x alone and say 2 minus 5, negative 3. All right. It wants my co-vertices. My co-vertices are my ones that are on my smaller. So now I'm going to move my x value. I'm going to leave my y value alone and move my x value, okay? So I'm going to leave this 2 here, and I'm going to look at what's under my x. Well, what's under my x? Technically, it's a 1. Square root of 1 is 1. I'm going to add and subtract something from my x. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. That's my co-vertices. And then it wants my focal points here. All right, those will always be on my elongated. So whatever I moved with my vertices, that's what I'm going to move with my foci. So that means I'm going to leave the negative 2 there in my x. I'm going to take that positive 2 and I'm going to add and subtract c. In this case, c is a squared minus b squared. So c squared is going to be a squared, which is 25, my larger one, minus b squared, my smaller one. So c squared is going to be 24. C is going to be the square root of 24. If you simplify that, that's 4 times 6, or 2 squared is 6. All right? So my foci is going to be 2 plus 2 squared is 6. Leave that negative 2 in the x, and 2 minus 2 squared is 6. And I've answered all the questions. I just need to graph it, right? Graph your center. Negative 2, 2. Graph your vertices. Negative 2, 5. Negative 2, negative 3. Graph your co-vertices. Negative 1, 2. Negative 3, 2. Oh, and I think I went too far down. No, I didn't. Maybe not. Here. This one's right. This one's wrong. There we go. There we go. Much better. Thank you. So that means I need to move him up, not the other one down. Better? Y'all could just, you know, tell me when I'm... By the way, this is identical. Endpoints. This is where you can find your center by doing your midpoint, right? The distance between the two. Major axis, what's changing? My y value. So this is going to be opening on the y, right? So that means my center is going to be at 7, and then the average of these two, which is 0. I know I'm opening on the y, so I know my larger is going to go under my y value there. So this actually tells me my A as well, my endpoints of my major axis. If this is my center, which is the average of the two, then my A has to be 10, because that's how far away from my center I'm moving. And then this will tell me my C value. How far away from center am I moving for the foci is my C. So I actually know my C value is 4 squared is 6, which I can then find B, right? Remember, C squared is A squared minus B squared. So if I know my C and my A, I can solve for B by just plugging it in. So B squared is going to equal 10 squared minus 4 squared is 6 squared. We have 100 minus 96, B squared is 4. And I really just need my B squared. I mean, unless I'm using it for something else. Once I know that, I can actually, that's all I need to give the formula. I don't need to find anything else. I need my A, my B, and my center for this guy. I do need to figure out that it opens on the Y. So the larger of the larger of those two is what's going to go under the Y. But then I'm just going to plug it in. It's going to be X minus my H. My H is the Y X coordinate of my center. That is squared over my smaller one because it opens on the Y. My smaller one is the 4. They're both plus when it's an ellipse. Y minus 0, that's just Y squared over my A squared, remember, so over that 100, and that equals 1. So once I have my center and my A and B for an ellipse, that's all I have to have. I don't need to try to find anything else there. I don't need covertices. I don't need any of that when I'm just giving the formula. Did hyperbola. So hyperbola you can think of as an ellipse subtracted. So instead of them moving towards each other, they're moving away from each other. This guy is determined by which one's negative, all right? Negative and positive. So if the X group is positive, then it's going to open on the X, left and right. If the Y group is positive, it's going to open on the Y, up and down, all right? This does not matter which denominator is larger or smaller. The larger will not always follow one or the other, okay? It's just how it's going to work out. So it really matters which group is positive and which group is negative. And then it is going to move accordingly. So if it opens left and right, then from your center, which is still HK, you're going to have two vertices, right? You're going to have a vertice for the parabola type piece on the left, the parabola on the right, and you're going to move your X value to get that. If it opens up and down, you're going to be moving your Y value to get that. And you'll notice that when it moves left and right, it's the value under the X that determines how the X moves. If it moves up and down, it's the value under the Y that tells you how to move. So you don't have to worry about which is A, which is B, right? You have to worry about which value is under which. Here you do have asymptotes. The asymptote is always the value under the Y over the value under the X, Y over X. Keep in mind, those values in your standard equation are squared. So when you go to your asymptote, take the square root, okay? Because that's what you're using. When you move your center to get your vertices, the value that you're looking at is squared. Take the square root to move it, or else you're going to go way off the graph because you're going to be squared. All right, so if you get these and you go way off the graph, you probably didn't take your square root. All right, so these are the formulas. I've printed them out all for you. You should have all of these, all three of these, and that's what you're going to be working on for knowing what to do. But try not to get caught up in the A's and B's. Try to think about like for your ellipse, think about which one's larger, which one's smaller. For the hyperbola, which one's in the negative group, which one's in the positive group. Because you're going to get messed up in what is A and what is B, and you're going to confuse yourself. Just think about what directs it, and not so much what the letters are. All right? Remember for this one though, your C value adds the two, right? It's A squared plus B squared, not minus. for this one. So for this one, I'm going to leave this alone. I'm going to say 4y squared minus 25x squared. I'm going to move that 100 over. I do that all the time. You probably can see what's going to happen. If you had completed the square, you would need to factor something out. So if you had like a plus 2x or something, you need to factor out so that you complete the square. But these don't have any single variables to the first power that you have to worry about completing the square. So for this one, all I have to do is divide by that 100. Right? So 4 reduces, so I have y squared over 25. The 25 reduces, I have x squared over 4, and that becomes a 1. So my center, even though it doesn't ask for it, I always start with my center. Because I'm not adding anything to it, my center is actually going to be 0, 0 here, right? That helps you tell where your asymptotes are going to cross, by the way. So when you figure out your asymptotes, it's going to have a b value of 0, all right? From there, I'm going to find my vertices. If this is opening on the y, which is, I know that because of this right here, then when I try to find my vertex, I'm going to take the number under the y and add or subtract it to my center. So I'm going to take my center, remember the value under the y is being squared, so I'm going to add and subtract 5 from my y value here. So my vertices are going to be at 0, positive 5 and 0, negative 5, right? It does ask for my foci points, right? My foci. So in order to do that, I need my C. Remember for this guy, he doesn't subtract the 2, he adds them for the C. So your C squared is going to be these two values added together, 25 plus 4. So it's 29. So that means C is the square root of 29. So for my focal points here, I'm still, because it's opening on the y, I'm still going to take my center and I'm going to add and subtract the C now. So it's going to be positive square root of 29 and negative square root of 29 here. Add or subtract your C. Asymptote. Asymptotes are always going to be the y over the x. It doesn't matter which way it's opening, all right? Because it's y equals mx plus b. So to find this, I am going to do y equals, and then the value under the y, remember he's being squared, so we're going to say 5 here, over the value under the x, remember he's squared, so we'll say 2. And normally you would have an x minus your h quantity squared plus your k, but those are both 0. So it ends up actually just being y equals 5 halves x squared, not x squared, we're not squaring it. And then y equals negative 5 halves. All right, you have both of those. If you had an HK, you would need to distribute and simplify into y equals mx plus b form, okay? But my center is 0, 0, so we're good. If I graph this guy, so I usually start by graphing these, just because it gives me an idea of how steep this thing is or stretched out. So when you graph these, that's why you want it in slope-intercept form, y equals mx plus b. This specific one does ask for eccentricity. Remember, eccentricity is always c over a. So my eccentricity is always my c, which I found to be square root of 29, over my a. Remember, the a in this case is the larger one. So that is, the a here is the one under your positive. If you were doing your ellipse, it's your larger one, okay? So look for the positive one here. For an ellipse, look for the one that's bigger. In this case, it happens to be both. So I'm going to go to my positive group and take the guy that's under there. Remember, again, he's being squared. So my eccentricity looks like that. All right, so I've really found all my pieces and I can graph. I'm going to start by graphing my asymptotes. They are starting at the 0 and going up 5 and over 2. So we're going to graph that guy just like we would any slope-intercept form. Start at your y-intercept, move by your slope. And then the other one is a negative 5. So you can go down 5 and right, or up 5 and left. But he should be intersecting at that center. Even though it doesn't ask for center, it does help you see where your asymptotes are going to cross. All right. Then I go to my vertex. 0, 5, 0, negative 5, right? You don't, in this case, I don't even think it makes you graph the focal points. The asymptotes actually help you the most because he's going to do something like this, right? And then he's going to go down below it and do something like this, right? So if you have the parametric, they want you to write it in terms of y and x together. And then the next group is just doing the opposite. So for a trig function, it's either going to be sine squared plus cosine squared, or it's going to be your tangent and your secant is about all you're going to see here. So write it in terms of t. So here t, we're going to leave the sine with the t is x over 4. The cosine is going to be with the t, that's y over 5. Sine squared plus cosine squared equals 1. So we're going to say this squared plus my cosine squared equals 1. And you're really done there, right? If you have something like this, you need to rewrite them. Rewrite one of them in terms of t and then plug it into the other guy. So like if I were to do this one, I would take this and square both sides. I would say x squared equals 6t. So t is going to equal x squared over 6. And then I'm going to take him and plug him in. So I would say y equals negative 6 times x squared over 6 over 5. Those cancel. Y equals negative x squared over 5. This does have a limitation. At the very beginning, we had a limitation because we had a root. So in this case, my limitation up here was that t has to be greater than or equal to 0. Apply that here. That means x has to be greater than or equal to 0. Based on this limitation, you automatically know that's going to be the same one because they're the same thing. So this one you didn't even have to solve. Had it been like x equals t plus 1, then you would have just set t plus 1 in between your negative 5 and positive side and solved for your x limitation. So like for this one, I actually already have one of my parametric equations. X equals t was given to me. So that means just rewrite him plugging that in. Instead of x, write a t. So y equals negative t squared over 5. And you have both of them. And sometimes it's not as simple. Sometimes you have to simplify your t, a little bit more, like in maybe 25. You would have to multiply by 6 and take the square root or something to plug your t back in to get your x, what your x is. But you need to just solve for what you're plugging back in. So one way you're getting rid of your t's and writing it in a y equals x form. The other way you have your y equals x form and you're putting your t's in based on one equation to the other. The key to word problems was figuring out which of those equations we just talked about they're talking about, right? In this case, we have an arch of a bridge. An arch of a bridge looks like a parabola, right? If you were to draw a bridge, right? Beautiful, right? The bridge is going here. These are the formations that hold it up, pretty much is what they're talking about. Or an expansion bridge, it may be the arch that holds up with cables coming down, whichever one. If they don't tell you, center it at 0, 0. They actually force you not to do that, okay? They actually say the arch is 25 meters high, so we automatically know that this guy is at a y value of 25. But then it says, they give me the base, 52. It says, write a standing form equation that models the arch with one base at the origin. So instead of centering at the origin, they've actually told me that this guy is at the origin. So that means this guy is at 52, 0. And that means the 25 should be right in the middle. So he should be at what? 25, 26, 25, right? So they've already told me my vertex. My vertex is at 26, 25. They told me my H and K. All right? Does everybody see how they told me my H and K? Yes. So here's what I'm going to do. I need to figure out the standard form of this equation is basically what they're asking me to do. Write a standard form equation. That's really all they're asking here. Standard form equation of a parabola that opens up and down is y equals a x minus h quantity squared plus k. All right? Here's the problem. I only know 2 of the 3 that I need to know, but I know 2 points on my parabola, correct? So I can plug those in for x and y, and then I just have 1 variable left to solve for, a, right? Me personally, I'm going to pick the easiest point. I'm going to plug in a 0, 0. So I'm going to take this equation, I'm going to plug in everything I know. I know my h and k, and then I'm going to use one of my x, y's to plug in as well to solve for a. Then I'll rewrite it with just my a, h, and k plugged in, right? So I'm going to say 0 equals a. I don't know him yet. I'm using the point 0, 0 for x is also 0. My h is 26. My k is 25. And then I'm just going to solve, right? So subtract my 25. I have negative 25 equals a times 26 squared. Divide by 26 squared, which is 270 or 676. So a equals negative 25 over 676. He's not pretty, but he's negative, which is what I should expect here if I'm talking about an arch holding a bridge up, right? So now I have my a, I have my h, and I have my k. I can write the formula, right? So my formula is y equals a, negative 25 over 676. X minus h, my h was 26 squared, plus my k, which was 25. And there's my formula for my parabola. For this one, you need to remember x equals my initial velocity times the cosine of my theta times t. My y equals negative 1/2 my gravitational pull. Remember, gravitational is 32 for feet per second and 9.8 for meters per second. Squared plus my initial velocity sine of theta t plus my initial height. All right, so plus my initial height. All right, write equations modeling this guy. It says quarterback throws a football at a height, that's my h of naught, initial height, with a 20-degree angle of elevation, that's my theta, speed of 60 feet per second, that's my initial velocity. So parametric equations are just a matter of plugging it in. X equals initial velocity 60 times the cosine of my theta, 20 degrees, times my time. Y, we're talking feet per second. So negative, that's a t squared, by the way, negative 1/2 times 32, so that's 16 t squared, plus my initial velocity 60 times the sine of my theta, which was 20, times t, plus my initial height, which was 6.3. Those are my initial parametric equations. Those will be the same for this type of problem. Find the height of the ball after 1.2 seconds. Which of those equations would I use for height? Y. So I'm going to take 1.2 and plug it into my y equation for that one. How far down the field did it go? Which way am I talking now? Horizontal, right? So I'm going to take the 1.4 and plug it into my horizontal to answer that question. That's how these are going to look. They're just testing. Now, they may say, did you clear a tree at this time? So now they want you to plug it in and say, how high did it go? Did it clear the 10-foot tree, right? So it's going to be a variation of these repeated over and over for those type of problems.